Yes. I used to divide both of those numbers by 0.001. See your answer. One of those.
Yeah.
Can you read that? And then. 2 hours. Yeah, no problem.
Right. Let's try a question that we were practicing yesterday. So, we already talked about the first two sections. Obviously, you guys have some questions. So let's try to work out a few more practice questions. Well, is that yours? Oh. So on the board we have a question. It's about the calculation of the definition limit in the process trying to determine or prove the limit. We have to find the correct delta. So let's try to review what we started yesterday. That you are to try to prove the limit of root of x, and we're going to see that root of x when x approaches 4 is 2. In order to use the limit definition to prove this, we have to prove that for any positive number epsilon, its notation is representing positive, we can find or there exists. When we say something exists, we gotta identify it. There exists a positive number delta. That's kind of the reason that this definition is called epsilon delta definition. So that's epsilon, that's delta. We will be able to search that for any x value. Whenever the x minus 4, trying to get x to be close to 4, so x minus 4 gonna be smaller than delta. So delta is a small number. We're forcing x and 4 to be really close. So how do we know they're close? You subtract them, the answer is a really small number. That's how we can know that they are really close. So x is approaching 4. So for any x value that is close to 4, close enough to 4, we have the target result. The result is that root of x will be close to 2. So root of x minus 2 will be less than epsilon. That's pretty much the definition. As you can see, this is a pretty abstract. As you are trying to determine the delta, you are trying to find the relation between the epsilon and delta. So if I pick a epsilon, you're gonna present a valid delta. So these two actually have underlying relation. In the actual proof, delta very likely would be a formula involving epsilon. Now, on the board, we have a solid question because instead of using an arbitrary epsilon, here we have a single epsilon that is a 0.7. So suppose we choose the epsilon to be 0.7, how can we choose the delta? So the x minus 4 less than delta causes the root of x minus 2 less than 7. There's a relation between the two because if the x is closer to 2, closer to 4, root of x is supposed to be closer to 2. Visually, it would look like if you draw the graph for the root of x function, this is how the graph. Okay, so this is the graph for y equal to root of x. And we're saying if the x value is close to 4, let's see, this is where the 4 on the x-axis, then the y value is supposed to be close to or approaching 2. The idea. So now we have a targeted epsilon. In this case, we're saying the distance between root of x and 2 is less than 0.7. So you're staying within 0.7 radius of 2. So visually, you will have you can be higher than 2 by 0.7. So that would be 2.7. Or you can be lower than 2 by 0.7. That would be the 1.3. So this created a range, an interval of y value, and then that causes you being able to construct a interval of x value. So this is the y value. My drawing is not perfect. So then we can, on the graph, using the x value, we can create a boundary for the x value. And now we need to know how large this is. We need to know what's this. Okay, what's the distance here? And this 2 number, whichever is smaller, are going to be the one we're using as the delta. How large is that radius? This is how we visually identify delta. Right. So this is pretty much what we were doing yesterday. If you have some idea on how to calculate the delta, let me know. If you don't, then I'm probably going to start writing on the board about how we determine the delta given an epsilon. So with any given, that's right, with any given epsilon, we should be able to determine the delta. It can be formalized. It can also be. All right, so let's repeat this process. So we kind of like starting from here. This is what we wanted. And then from here, we're going to go back here. So you're going to start with root of x minus 2 is less than 0.7. And when you are solving a equation like this, looking at this is actually an inequality because there's inequality symbol instead of equal symbol. So the number one thing is to remove the absolute value. And I was talking about relation. If you have absolute value of a number less than epsilon, as a result, the number must be less than epsilon or larger than negative epsilon. So this is really equivalent. Writing it that way, the same as writing it this way. This way is easier for us to get to it. So this is the process of removing absolute value. So removing this absolute value, we have root of x minus 2 less than 0.7, bigger than negative 0.7. So this is the first thing we do is to remove the absolute value. And we are hoping to get a boundary for x minus 4 absolute value. So now we are only at root of x. So we have to slowly solving the x, or slowly have the x isolated in this process. Remember what we do next?
We add 2 all sides.
Add 2, add 2, add 2. So we're adding 2 to all 3, and then the middle one, we achieve one thing that's cancel the 2. We have root of x by itself, and here is 2.7. Here is 2 minus 0.7, 1.8. So that is the same boundary that we observe in the graph that was drawing, right? You go from 2, you go up, and you go down, 0.7 either direction. That give you this interval, and that's really the interval that we indicated. So interval is really another way to represent inequality. So if we have inequality, then we have an interval. They're actually the same. All right, what do we do next? So we square all three, so we square. This you square, you get x, that you square, you get 2.7 squared. And here you square, you get 1.3 squared. All right, so that then we like compare it from what we have now to what we wanted to have. Then what do we do? So it's all three of them. 4 minus 4, 1 minus 4. So now we're able to identify the boundary for x minus 4. So we have x minus 4 less than 2.7 squared minus 4, bigger than 1.3 squared minus 4. All right, so that is the boundary for x minus 4, but we intend to find the boundary of absolute value of x minus 4. So now we have to do one more step, that is take absolute value of all three. But when you take absolute value of all three, we will not be sure which one is smaller. We really wanted to find a boundary, and boundary can only be small rather than big. So you take absolute value, and absolute value. This absolute value and this absolute value, whichever is smaller, will be the answer. So the answer will be this is less than the minimum of the two. There's absolute value of 2.7 squared minus 4, and there's absolute value 1.3 squared minus 4. Whichever one of those two that are smaller will be the answer for delta. So the process is very typical, but it can be repeated even for the abstract case. So if it's not 0.7, there's 0.7 here. But if it's epsilon, we can actually repeat the same thing and also find out delta. The delta will be represented by like minimum of something and something. But that is going to be a formula if you have an abstract case. All right, I hope that kind of explained the process of getting to the number of delta. All right, hope that you finish the last step of the calculation. Know what was your answer? The entire code has to be in the window. That one was in the one. Yeah, not that one. Repeat the calculation compare. It has to be the smaller one of the two. The delta that we choose should be, you have to find the decimal number. Yeah.
You didn't pick up my card, did you? Or like you didn't pick up
the side that was.
It will be.
I'm sorry, I was asking like the answer didn't pick up the
Yeah, let's see whether so far all the answers I picked up are right, are correct.
Okay. Yeah, because I didn't want it to be accidental. I didn't want the wrong answer to be. I don't want to accidentally.
Right, sometimes the standard accidentally pick up the wrong head if your card is facing up. Try to get your card face down. The scanner scan any image that has a QR code. It doesn't matter what's in your hand or on the table. Make sure. That's something like that. But let's do a calculation. Where was it? It was here, right? So you have 7 minus 4 and 1 what's your number? So you go 7. Oh, 1.7. 3 squared minus 4. Yeah, so that is 2.31. That's minus 4 will be 6.2. We choose the smaller ones. That's yeah, the other one was larger. That is smaller. Right. I think I have recorded all the answers in the class. The answer is supposed to be 2.31. Let's double check your calculation, kind of understand the reasoning for how do we get from the beginning to the end of the calculation. All the calculation that we've done is already on the board. So you can double check if we are on the same page. If you got a question, let me know. Any question? All right, just trying to use one question and also record class attendance at the same time. So if you were later, like you came in the class later in the day, like 10 minutes after class, and this is already done, let me know before after class. Like I was a little late, and then I still want to get my attendance recorded. I'll take care of that. That way we won't forget, and you will not be accidentally counted as absent. All right. You guys have some question about the homework? Let's look at the web for homework and see if we got any harder one that we can compare it. All right, so there are two sections. Each section has roughly 10 or a little bit over 10 number of questions. Which one was giving you a hard time? I guess. Alright, so this is question number 9. The function is y put x over 1 plus x. That's how we calculate the y value for each point. And the question says we have one point that's not changing. So p is when x equal to 1. So 1 over 1 plus 1, that's 1 over 2. So that's x and y. X equal to 1, y equal to 1 half. That point stay. And then we have a point that's moving. So the point Q has a coordinate x over 1 plus x. That is a point that changes when the x is changing. So we're trying to find the slope of PQ, Q being the one that needs to be calculated. All right, so let's start with the first one. The first one saying we want to find the slope of the line through PQ. So P is 1 half, and Q is 0.5 over 1.5. So I guess I could.
So that part, actually, that was.
So that part was okay.
Yeah, the bottom where it says you have to find the slope.
So you were able to find all these?
The very bottom.
Okay. So you guys are also the same? Any difficulty at the beginning? All right. So we're okay, but kind of want to say what was the answer. So the most indicative is maybe the number 8. So let's see. We got number 8 calculated. So the denominator should be 1.01 minus 1. That's 0.01. The numerator should be the 1.1 half is the y value. So this y value must be the 1. 1.01 plus 1, 2.8. Even though we're close enough number to find the slope.
Yeah, so.
Right, x is 1.001. The denominator is 1.001 plus 1.
Tell us where it goes. So I'm going to.
All right, so this is the number I'm trying to redo it so we can have an estimation of it. So roughly we can see it started out 0.33 and then 2.6 and this is 2.19. So the closest enough will be 0.25. So we have a slope estimation. Using those numbers, we estimated the slope to be 2.025.
I couldn't figure out how to do it.
The last one. Last one says using the slope form from B. So we have the slope. All we have to do is draw the line, find the tangent line. Tangent line is still an equation of the line. So if you are trying to calculate the tangent line, you need we're probably going to talk about how to determine the equation of the line. any equation can be determined by two factors. You can have, try to summarize them before.
So then it's slope.
Yeah, to determine equation of a line, any line. Any line is also a line. So setting up a linear model is something we often have to do. So in order to determine equation of a line, and there are a couple ways to do. Y equal mx plus writing down formula for equation of line. So if you have the slope, which is called m, and the y-intercept b, this will be the formula for the lines, where the m will be the slope, which we have right now, and then the y with the b be a number for the y-intercept. That's one form of equation of line. And then the other form of equation of line is y is equal to m times x minus x0. X0 is the exponent plus y0. So this is assuming you have the slope, which is m, and assuming you have a point on the line, and it's the x0, y0, the equation of a line using one slope, one point. We also have, yes, that's the two of the most common one. We have other ways to determine the line. Suppose you have the intercept. You can go x is over a plus y over b, which assuming you have a is the x-intercept, right? And then b is the y. And we don't use this one as often. The first two are the most common one. The last one is when you have the intersect, and it's, for example, you got x-axis, y-axis, and you have a line. So right here, this is your x-intercept, it's called A, and this is your y-intercept, that's called B. So this is also possible, but less common, but these two are the ones that we very likely will be applying. So for example, this question, we already knew the slope. So see this one, we don't have the slope. You might have to use A and B to construct the slope. In this case, it would be negative B over A right here. So our question, B equal to 0.25. And we also have point, and the most obvious point would be the point P, right? Okay. So we have a P that goes point P, and we have 1 and 1/2. Okay. So since we have the slope, we have the points, it's easiest just to apply the second formula to determine equation of line. Basically, equation of a line can be determined when you have 2 points. You have 2 points, but normally if you have 2 points, what we're gonna do is try to find the slope, and then use one of these. The y-intercept can be calculated. Right. So equation of line for this question would be y is equal to 0.25 times x minus 1, because that was the x value, let's say 1/2. And that's how we construct the equation of the line. I hope that's right. So that will be how we answer this question. The y is already in the question, so we'll just write the right side of the equation. And that should be the last part. I assume you guys are okay with this. I mean, there's a sequence of calculation, but they're all we're doing similar things. Any other question for the homework? Yes.
Number 6.
6. Okay. It says to sketch the function, use it to determine the value of A for which the limit does not exist. You can see the function is piecewise defined. You can draw the graph yourself, or you can use a computer to draw the graph. And let me try to draw it on the board, and then we'll use the computer to draw it one more time. Right. Well, my drawing will not be great today. So let's do it. All right, first we will have the axis values, y-axis, x-axis. Number one is let's draw the first one. It's piecewise defined. The first one has x minus x is less than -1. So on the x and -1, you find the -1 on the x-axis. Right, and then the other is 1, so you find the 1. All right, so there are basically three keys piecewise defined. All right, then let's start drawing the first one. Less than -1, we have 2 minus x. We can only use x value that's less than -1, so we can take, for example, for -1, 2 minus -1. 2 minus -1 is 3. So, if x equal to -1, the y would equal to, or roughly equal to, for the left piece, would be 3. Less than -1 is 3. And we find -1 and we find 1, 2, 1 point. All right, and let's explain what I'm doing here. It says 2 minus x, and the x is degree 1. A degree 1 equation represents equation of a line. So in the first piece of the graph, we're supposed to draw a line. And then if you want to draw a line, all you have to do is you have 2 points. So I'm trying to determine point 1, that's x equal to -1, y equal to 3. We need one more point that x is less than, x is smaller than -1. So let's pick -2. So if x equal to -2, that'll be x equal to -2, and 2 minus -2 is 4. All right, so we have -2 and 4, -2. This is already 3, so 4 is 1 above this. So we connect them. All right, so that's the left piece. It's kind of give us the direction. It has a -1 slope. -1 slope means the function is decreasing at 1 unit at each time. All right, the middle one says x. So from -1 to +1, the y value equals the x value. That means if x equals -1, y equals -1. So we identify the -1, which is right here. And also, if x equals 1, y will also be 1. So 1, 1 will be here. Drawing this good, but graphically it looks like this. Okay, so this is the middle piece. Yeah. But it's not. It's supposed to go to the origin. Okay, so like this. In that case, maybe the -1 is not marked else. Right. So this is how the middle piece, y equal to x, and then the last piece is x squared, x minus 1 squared. Because the square, this is degree 2 equation, degree 2 polynomial. Degree 2 polynomial is parabola. The center of the curve is at x minus 1 is 1. Right here at 1, we're supposed to draw a parabola like this. If x equal to 1, 1 minus 1 equal to 0. So right at 1 is going to be a 0. So it's roughly like this. It's half of the parabola. It's supposed to be like this kind of parabola. Symmetrical about x equal to 1. But we don't want the left, we only want the right side. Because it says x is bigger than 1, so it's on the right side of the, x is on the right side of the 1. So visually, that's how it looks like. And that's pretty much the piecewise defined function. And you can see the discontinuity. The graph made a jump at -1, and then it made another jump, which is a jump down at +1. So -1 and +1 are two of the part that does not have a limit. Question. Questions? Did that answer your question?
For the first one, what do you get, or how do you get the three?
The three, it's x equal to 1, so 2 minus negative 1. 2 minus negative 1 is 3. 2 minus x.
Why do you use negative?
Because that was right at the boundary. It's supposed to be empty, but still that still indicated the location. So there's supposed to be like a little empty dot because there's no equal sign. But still, as you are graphing, for graphing purposes, we still should identify the location, even though it's supposed to be empty. Kind of like what happened at 1. This side is also empty. And this one is solid, but the other side is empty. Because it doesn't have an equal sign at 1, but it does have an equal sign at the negative 1 for the second. Any other questions? Oh, let me graph this one for how it looks like on the computer. It is a lot easier graphing with a computer, but it helps to know both ways. So the first one we have 2 minus x, but we only want it when x is less than negative 1. So that's first part. Second one is like x. We want x is between negative 1. Yeah. So that's that piece. And the last piece is y equal to x minus 1 squared. And for that, we want x to be larger than 1. And that's how it looks like if the computer does the graphing. My graph is a little off as far as the height. The 3. So that explains. And then there is a limit until we reach here because our jump. Remember, if the function have a jump, or if the function have an offset decreasing, increasing process, or if the function absolutely infinitely, that's when we do not have a limit. So this function, one limit at negative 1, that does not exist. Limit at 1 also does not exist. So let's see, question 10. It seemed to be the one that we were using on the computer. You were the one asked the question about it?
Oh, wait, what?
I mean, yeah.
Like number 10?
Did you ask number 10? Yes. What do I fill in? Yeah, these should be the velocity.
Was it going to do them on the sides? Or
Yes. Okay. So this is the motion. We had this one yesterday when we were doing the paper question. The A is to find the average velocity. B is to find the instantaneous velocity. So 1, 2, 3, 4 are the answer for A, and then we answer B, which should be the limit that we identified from 1, 2, 3, 4. Okay, so let me copy this question and work through the process. All right, so let's start with this 1 to 4. The average velocity, it's really the slope that we're calculating. So we're trying to calculate slope of this function from a point to a second point. Let's start with the first question. Visually, it's kind of like this is like this motion. So we want to know what was the height when the t equals 1. So calculate 1. What was the y value? And the y value would be 58 minus 0.83 minus 0.83 times 1 squared. Right, and then we will calculate what happened as t equals 1.5. So in the original definition of the function, you would substitute t for 1.5 and we'll calculate the y value as 58 times 1.5 minus 0.83 times 1.5. So I'm calculating question number 1, and this will give us, use a calculator to finish y value, and that will be calculated y value. Once we have this ready, have both of these, you can consider them as x value or you can consider them as t value. This question we use t to represent times. And we find two different y value, one for the earlier time, one for a later time at t equals 1.5. And then we're going to try to calculate the slope. So the average velocity is the slope of the position function. So what we're going to do is we subtract the y values, which is going to be 8.5 minus the 0.17, and it's divided by the 1.5 minus 1. And that's how you enter division in the calculator. Right, so this is going to be how we answer the first question. Will not be able to. I wasn't able to get it, do it. 85.1325 minus 57. Still doesn't look like it. Okay. So that is the answer for number 1. All right, and then we can enter it. All right. We do the same thing for all of the first one. Are we okay? And then you can, I did the calculation from a calculator and enter the final answer, or you can enter the entire calculation in here. For the first, for example, the second one, what we can do is, it's really a division. The denominator is supposed to be a subtraction of the two x value, it's 1.1 minus 1. The numerator is supposed to be calculating the two y value. How do we calculate the y value? We use a formula. So the first y value, the 1.1, has a y value 58 times 1.1 minus 0.83 times 1 squared. That is one y value, and we have to subtract this the y value at 1, and that we have it already calculated. That was 57.17. If you intend to calculate it over here, it looks like this. It's going to be, I have to put parentheses around it. 68 minus 0.83 times 1. Turn this off. Okay. So you can see how the calculation is from the layout. The denominator is subtraction of the two time, and numerator is subtraction of the two y values. Any question? All right. The reason I repeat it again is because now we can actually repeat the same thing for all of them. All you have to do is to change your change the denominator. For example, the last one's supposed to be 0, 0, 1, and then the process can be quickly repeated. We kind of say the product, and this one has a here.
Yes, could you
It's basically you put the answer for 3 and 4, like down in 4.
Right, I think I put,
Yeah.
thank you.
Yeah, B is.
Yeah, it's like its own separate answer.
Hopefully, that answered the first four. So I just want to show that this can be all compared and they were all calculated in a very similar fashion. So if we kind of see what was the calculation being done for the previous one, we're repeating the same calculation for the following. Right. And then, well, the reason I have to do all four instead of just doing one, for example, because I need to see the tendency. So one of the reasons that we do numerical calculation is hoping to find if the average velocity for a shorter period of time are these, then what was the instantaneous velocity, which will be a limit version of all these. So you can see 55, 56, 56.33, 56.339. So I'm guessing the final answer will be 56.34. So we have not talked about the derivative calculation formula. So right now we have no formula to work with. All we work with is these numbers. So we're using this number as indication where everything is going. So the slope is 56.339 or 56.34 according to numerical calculations. And that seems to be where it's question number 10. Any other question for the homework? Try it yourself, and if you still have any difficulty, I'll be in the math lab upstairs right after this class. I'll be there until 10:45. The schedule. All right. About the second section. Have you tried it? Do you have any questions? Yes?
Push on problem 2.
Shoot. So this question, I guess one of the difficulty is having a formula to work with. It says here we need to make a circular metal disc with area 1.75. Let's try to analyze what's going on. There are a little bit geometry involved. All right, the target is to get a circular metal disc, and we have an area requirement. So let's just say we need to know the relation between area and so. How do you control the area? You control the radius. So we need to know relation between area and radius. Do you know for a circle, what is the relation between area and radius?
I times radius squared.
Height times radius squared. So it goes area is equal to I times the radius. So that's the formula. So having that formula, you can already start calculating the radius. That is, if the area is required to be 1075, then we will have 1075. It is equal to pi times radius squared. So to answer the first question, what is the necessary knowledge? Is to know if you got a radius, if you got the area, how to calculate radius. So we are solving the R from this equation. So we solve the R from this. But if you're taking square root, the pi will be in the way. Right. Okay. So we would divide both sides by pi first, and then you get 1075 divided by pi. And that's the actual number in the measurement. This is equal to R squared. Then what do we do?
You square root the answer to that.
Okay. So we would have R is equal to square root of 1075.
And that's pretty much what we're gonna answer the first question. So just square root of 1075 over pi.
Let's see what it is. So the formula is this, because we're using the formula to calculate, but the actual number is 18.4981. So let me round this to 4 decimal, 18.4982. Let's see if that works. So it looks okay. But sometimes I have doubt about the accuracy. Some questions require 4 decimal, some require 6 decimal if it's a really small number. Some is okay with 2 decimal. So I'm trying to test it out, like how many decimals should I put in so the computer will be happy. So that's kind of the reason why many times I put in the formula. If I use the actual answer, the exact answer of the formula, I don't have to worry about accuracy. But if you put in decimal number, you have to think about, is the number accurate? So that will be okay. And then so let's move on to the second question. To keep from blowing a gasket, we must deviate from the ideal area of this, which is 105 by less than 5 inches square. How close to the ideal radius must flow jet be to maintain tranquility at OCC, Orange County Charters? So basically, we're thinking about if you deviate from 107. So if the area is not 1075. It can be slightly different, but it cannot be too different. In order to control the area, your radius can be slightly different from the 18.982, but it cannot be too different. So here we're going to try to identify the closeness to the ideal radius. And that's kind of the same as how you want to be the delta that we're calculating. Essentially, we're trying to find the delta. Hope that makes sense. All right, so let's try to make it more mathematical, and then we try to make it similar to the limit calculation that we had. So basically, we got a function. Instead of calling it r, let me just call it x. So we have this f of x, which is equal to pi x squared. It was supposed to be pi r squared, but writing it x squared, it's easier to think of it as a function, pi x squared. When we are changing the x value, we're changing the pi x squared value, and the pi x squared value is the area. So the f of x is the area, the x is the radius. So that closest as a relation between the two. So now we want the area to be within 5 inches of the ideal area. So we are hoping that the area that we end up having, f of x, is close to 1075. So we want 1075 as our area. In real life, you can be, you hope to get that, but sometimes there are also slight deviation in real life. But we are allowing a small deviation. So deviation can only be as big as 5. That's what that 5 says, okay? If you are offset by a little, that's fine, but don't offset too much. So being off by 5 unit is okay. So how do we determine the x so that the deviation is less than 5? So we're like x gotta be close to. So we find out the ideal x. It was like 18 point. What was it? 198. Yeah. All right. This difference, we want it to be smaller than something, and that's the closest we're identifying. That will be the delta we're trying to find out. So now I'm trying to relate that to the limit calculation that we're doing, and this is something we want to be able to determine. So how do we do this? So it's
we're probably gonna repeat similar process as before. I don't even know if it fits all in here. So let's try to get rid of this so I have some space to work on. All right, so here we go. We will have the f of x is pi x squared. So we have our pi x squared, which is radius minus the 1075. It's supposed to be less than 5. You can, if you want, you can do pi r squared, but I like to think of the x value as independent. So this is what we intend to happen. Because f of x is supposed to be the area of the circle. So we want this, and then we're going to do similar calculation. Hopefully this kind of relate. So we would say that pi x squared minus the 1075 is less than 5. So we're removing the absolute value using what we were talking about earlier. So on the other side, it gotta be larger than -5. I hope that kind of recall what we were doing earlier. Are we okay so far? So this is the process of removing the absolute value, and then we are hoping to get x by itself. So we will see that the pi x squared, it is less than. Wanted to get x by itself, so all the process is to try to reduce what happened in the middle. So what we get here, what's on the right side?
Basically, the 1075 plus 5, and on the other side, like 1075 minus 5.
Which is
1070 and 1080.
okay. What you guys on the back? Are you able to see it? Because yesterday you mentioned that it was too low on the screen. Okay. I'll try to move it higher so it's visible. So this is 1080, and on the other side is 1070. At least that's the 1075 minus 5. And then we want to, it's very similar to when we're solving the radius. If you want to get x by itself, you first have to get rid of the pi, and then we'll take the square root. So the second step is to get x squared by itself. If you get x squared by itself, you have to divide them all by pi. So on this side, you have 1080 divided by pi. On the other side, you have 1070 over pi. And then we want have x. I mean, eventually we want to have the boundary of x minus 18.492. But first, you're going to have x by itself. So x is less than. You can see we end up having something very similar to what happened here. The r equal to square root of this over pi. But now we want to get rid of the square, so it's a square root. So square root of 1080 over pi is how you calculate that side. And the other side is square root of 1070 over pi. Running out of space. To make it different from the rest, it's not too crowded. Are we okay? All right. Then what do we do next? We want to get this has a boundary, right? It's the target difference. So let's do the subtraction. So we went to x minus 18 plus 4. It's less than. So on the other side, you have to do subtraction. And then whichever is smaller is our answer. Any questions? The board is kind of crowded, so let me do the calculation over here. All right, so we were to calculate both of these to the boundary. You calculate square roots of. we calculate square root of 1080 over pi minus the 18.4982. That's one. That's the boundary on the right side, and then you calculate something quite close, but it's the 70. But yeah, thank you. Right, now it's time to actually put in the calculator. Okay, that's what we have. One, the right boundary. We switch that to a 70. This boundary. All right. The important one is the absolute value. It looks like the first one has a smaller absolute value. That's going to be the distance I'm using. So I'm using this one as the delta. See if it's. That's how we identify. So number one, you identify the radius, and then number two, you identify the distance to that radius. Any questions so far? All right, let's see the rest. The rest is all about understanding what was going on. I mean, we're using the epsilon delta definition to determine all these boundaries. And then the rest of the question is the concept to understanding, like this one. What is the formula for f of x? And that's, you see me to define it over here. F of x is being defined as pi times x squared. So we over here enter pi, pi times x squared. That's how we enter pi times x squared on Webwork. What is the number a? If the a was the limit x goes to. And that one is the radius that we calculated, 18.4982. What is the final limit, which is a targeted area? That's the 1075. You want the area to be 1075. You're going to make that happen by making the radius to be 18.4982. So these two are closely related. One is the radius, one is the targeted area of the circle. What's the value of the epsilon given? And we were given the number 5. That's the required possible deviation. You can deviate from 1075 by a slight differences, but you can't deviate. The deviation has to be less than 5. So that is given. And using the 5, that's how we end up doing the calculation of delta, which would be the number that we did the calculation for. So the majority of the calculation is in question. The first two spaces that we're filling in, and the rest of them are pretty much a limited understanding of what the calculation are doing. Any questions? Okay, so this question's it's an applied problem that we try to make the applied problem relatable to the limit idea. That's number 2. Any other question for this assignment? Try the rest of the questions. This is number 5. I'm trying to go through a few examples. It says, how large must x be? So then, it's kind of like solving an inequality. This question does not refer back to the limit at all. So this is really solving an inequality. It's purely solving an equality without mentioning the limit. So we want to find the boundary for x value if we want to find the function have this boundary. So as you can see, when you work on the epsilon delta definition, you do have to work with inequality. So the process will be number 1. There's only one x. So if you are solving this, what are you going to do? Well, if you are comfortable with the equation, you can switch that less than notation to equal notation and solve for x. And the process will be very similar. But
let's see, we solve this. If you wanna get x by itself, we'll have to peel the outside of the equation. There's only one x, so we're peeling the onion. So you're gonna peel the outside first, and then this, and then this. So whatever is closest to the x should be peeled off last. So the first thing is the e. How do we get rid of the e? The inverse of e is natural log, yes. So we'll take natural log of both sides of the equation to go ln e to the power of negative x over 10. We take ln of the left side of the equation, which will be less than the natural log of the right side of the equation. So we take natural log of both sides of the equation. Natural log is a increasing function, so it doesn't change the direction of the inequality. Right? The part of the difficulty working with the inequality is it has directions. Equation has no direction, so you can do it one way or the other as long as you are doing it simultaneously to the right and left. So for inequality, you have to do it simultaneously to the right and left, and also you have to think about what your action, whether your action is causing the inequality to switch direction. Right now, there's no switch because logarithm is increasing. So it's maintain the direction of the inequality. After we've done that, natural log will cancel the e. So your left side of the equation will become negative x over 10. Because e and natural log are inverses, so they cancel each other. So this is less than here. So this is step one. Step one, we're able to get rid of the e part of it. And then what do we do next? Yeah, multiply by 10. So we multiply both sides of the equation by 10. The reason that we multiply 10 is because multiplication is the inverse of division. So if you divide by 10 in the original equation, multiply by 10 will cancel that 10. So multiply the left side by 10, and then we have negative x. Now you multiply the right side by 10, it'll just look like a 10 times. Okay, there's one last thing to do is get rid of the negative, and negative switch the direction of the inequality. So multiply negative on both sides of the equation, we'll have x is into the direction negative 10. In this step, you have to multiply -1 to the left side of the equation. You also have to multiply -1 to the right side of the equation. And then we have to switch the direction of the inequality because a -1 changes the order of the number. Right, that will be the answer to the question. You can also find the exact number or you can enter the calculation. So that's the answer to this question. It's an algebraic question on solving the inequality question. Three. Okay. This one saying which one? Well, limit equal to infinity. This is something that we have not talked about it yet, but I believe we do talk about infinity in college algebra. Infinity is a artificially defined boundary when there's really no boundary. So we instead of saying, hey, this y value has no upper boundary, we'll say the y value is going to infinity. So we put a arbitrary boundary where things are arbitrarily large. There's no upper boundary. We see that's infinity. All right. So the definition saying limit of f(x) when x equals 3 is positive infinity. Visually, it will look like this. And what kind of function behave like that? Let me just give you an example. Y equal to 1 over x minus 3 squared. Okay. So in this case, the limit of this function when x approaches 3, 1 over x minus 3 squared equal to infinity. Visually, it looks like this. This function 1 over x minus 3 squared is a rational function. It has a vertical asymptote at 3. So y as 3, if x equals 3, 1 over 0. If x equals 3, it will be undefined.
So this function is defined by a single equation. It actually has two parts, two completely separate parts as a graph. So and also because of the square, the whole y value is positive. So there's nothing below positive and small when x is going to go closer and closer. As we get closer and closer to 3, for example, 3.1. So 3.1 minus 3 squared 1 over the 0.001 is 100. So when x gets closer to 3, the number gets larger and larger. Okay, it happened the same way over here. Okay, so this is what happened when we see as x approaching 3, the y value is approaching infinity. It's bigger and bigger, and there's no boundary to the y value. So visually, it shows that the output of the function is getting arbitrarily large. So here are the verbal description. As x approaches 3, either side, left or right, from both sides, and then visually you can see f of x is getting arbitrarily large. And the last one saying we know where f of x is going, and then I guess we'll answer C. A and B only focus on one side of the function, but left side and right side of the function, it happens the same way. So I would say the answer to the statement would be C. So this is how we understand the notation when a function have a limit equal to infinity. It has to be the left side and the right side. If it's A, we would say the left limit, the right limit. So A would be indicating f of x when x approaching 3 from the right side is infinity. So if you want to represent A, you'll be writing this. And in the B, this is A. For B, you'll be writing limit of f of x as x approaches 3 from the left side is infinity. So A and B would have a different notation. C is represented by this equation. The equation represents either side, left side or right side. That's just an interpretation of the notation. This is the one that has, I think we talked about this one yesterday, right? We went over how to calculate it. I assume this one will be okay. And you will start from here and go 3.2 and then 2.8. It was here. All right. And then in order to get x, I solve your square. So you square 3.2 square 2.8. And then we have to find the boundaries. So we have 3.2 squared minus 9 and 2.8 minus 9. I believe we were answering it yesterday. 1.16. No. What was it? 6. We did the calculation yesterday. I believe it was like 2.8 squared minus 9. I picked the x value. I would say. Yeah, so this is a pure abstract calculation. So when things are more abstract, we tend to hesitate about what to do. One of the things you can do is follow the definition itself. So here it says f of x is 5x minus 2, plus negative 2 is the same as minus 2. So find the large delta. So we're going to find the determination of delta so that f of x minus f of a is less than epsilon. So obviously we're not given the a, so it's really a question that involves algebraic calculations. So you're going to write it out in the actual indication of what we intend to do. You analyze these two as a focus. You start from here, kind of that what we are doing before. Start with the equation involve epsilon and slowly transform into something relatable to the delta. So with f of x, we have f of x equal to 5x minus 2. 1, and we were supposed to subtract them, so we also need to know f of a. A is the algebraic notation, so replace x by a, we have 5a minus 2. Similar. So we're gonna go ahead and write out what we intend to have. We want to have absolute value of f of x minus f of a to be epsilon. Right, and that's the goal to have. We wanted to have, and then we want to achieve that by choose the right delta. So f of x and f of a are already, I'm expressing them with the formulas. We have the formulas for both. We can start writing it. F of x is 5x minus 2. All right, and then we have f of a, that's the 5a minus 2. I'm using parentheses to protect the order of operations. That's one step further on analyzing it. And then I'm adding parentheses just to make sure f of a is f of a. All right, and then we're going to remove the parentheses. It causes change of sign because the negative sign before the parentheses. So it's going to become this change color, so it's so we will get 5x minus 2 minus 5a plus 2 absolute value, and this is less than epsilon. Right, so same equation, we're slowly changing it, and then we realize that minus 2, negative 2, negative minus 2 plus 2 cancel. So you have a slightly shorter representation. So you have 5x minus 5a is less than epsilon. All right, so far that's all we analyzed for the f of x minus f of a. What we wanted to get is x minus the absolute value. We don't want to have this, but now we have this, right? Right? Your goal is here, but then you're here. You see, we're not that far away from that. The only thing we need to do is factor out the 5. So we factor out 5 out of the parentheses. We'll have 5 times x minus a, which is less than epsilon. All right, finally we have, let me change the color one more time to differentiate the column. And so we have absolute value x minus a is less than, guess what's on the right side?
5.
No,
Oh,
5 was here.
Oh, whoops. I was mistaken the direction.
Yeah, so how do we remove the 5s? Epsilon over 5. So answer here is epsilon over 5, because we have to get rid of 5 from the left side of the equation. So our target is to choose the right delta. So then this is happening. Obviously, when this is happening, you have x minus a less than epsilon over 5. So epsilon over 5 is a perfect representation for delta, because if these two are the same, we would have all that we wanted, right? You identify what you wanted to say, how do I make this happen? I gotta make that happen. That will be the delta. That's okay. So answer the question, we will type epsilon, you type epsilon for epsilon. So answer for the question will be epsilon over 5. And now we let you try to go through. I'll see you next week. Please finish your first two assignment. If you got anything, you're welcome to talk to me after class, or we'll ask for next Monday as well. I'll see you. Thank you.
We got it.
Yeah.
Okay, I'll just. Okay, I'll do that. Thank you.
I'll just
2. That's really bad. It's pretty low.